Hey guys, welcome back. Myself Namita from Information Science and Engineering Department studying at Sri Venkateshwara College of Engineering. So this video is going to be about technical seminar on the topic an IoT-enabled smart dustbin system. Let's get into the contents of the video. Firstly, introduction, related background, its working and implementation, application and future enhancement, conclusion, and the references. Introduction. Waste management is an increasing challenge in rapidly urbanizing areas, especially in countries like India. We'll have manual waste collection, like garbage collection. People will come and collect it manually. That is the systems frequently encounter inefficiencies in waste collection and segregation. Due to manual collection of waste, people coming and collecting the waste, there will be bins overflowing when they come late for collection of garbage, and also differentiate and difficult in segregating the waste like wet waste and dry waste. Hence, we require waste management solution for immediate monitoring and accurate classification of waste. Here we use smart dustbin system incorporating the Internet of Things IoT. What is Internet of Things? The IoT links devices to the internet and other associated devices. Like it will link many devices to the internet and form a network like collection of smart devices that collect and share information. Related background, traditional waste management systems usually depend on manual processes for waste collection and segregation, leading to problems like overflowing bins and difficulty in waste segregation. As I've told earlier, manual collection will lead to overflowing of bins and difficulty in the waste segregation. Recent technological advances have introduced IoT based solutions for management, like the implementation of GPS-enabled tracking systems for waste collection vehicles have enhanced resource utilization in modern waste management systems. The waste tracking system shows that the interaction between waste composition and collection vehicle design significantly improves the waste management system that results in advancing urban development goals. By implementing this IoT based systems for waste collection and GPS enabled tracking system, it will improve our urban areas even more. The literature survey from G. Ram Shankar, title named Implementation of Sensor Technologies and Strategies for an IoT enabled Smart Waste Management. This paper basically talks about using ultrasonic and weight sensors for knowing the weight of the waste deposited in the bin. That is, depending upon the weight, the waste will be collected, and it will also schedule waste collection the timings and the routes like shortest distance to reach that particular bin in the area. The merits of this paper was waste collection efficiency, cost savings, route planning, and also there are demerits, that is dependence on robust IoT infrastructure, challenging in diverse urban areas like Bangalore. And another paper, Zhu Wen-Tan and Ibnu Febri Kunavin, named the paper titled IoT-Enabled Garbage Management System, a Fair Perspective. This paper basically used sensors and LoRa communication. LoRa communication is something like we can send data for long distance using less amount of power. This paper was basically to uh, track solutions for truck routes and balancing the workload distribution between the trucks. That is, if there are two trucks available in the same area, that is where the bin is placed, then this system will find the shortest route to the truck that is nearby, and also it will distribute workloads equally to the trucks. The of this paper was to reduce travel distance, workload fairness, and cost effective. Demerits were LoRa network limitations, difficulty in dense areas, resilience on the connectivity. Next, working and implementation of smart dustbin. Basically, smart dustbin is used to build a bin where things are sorted smartly. That is, like the users will be notified with the waste fill level in the bin through a website, and also if wet waste is put into dry waste bin or dry waste is put into wet waste bin, it will send an alert message to the user through the website. Firstly, we'll require certain components. The hardware components are ESP32 microcontroller. It is a low power Wi-Fi and Bluetooth microcontroller for IoT applications. Connecting wires used to establish electrical connections between the devices. Ultrasonic sensors. It is used to measure the bin fill level with the waste using ultrasonic waves. And humidity sensor used to detect the type of waste using the humidity of the waste. Software components. Front end. In the front end, we have used HTML, CSS, JavaScript. Backend, Firebase for real-time database management and user authentication. And Arduino IDE for programming ESP32 microcontroller. Firstly, the ultrasonic sensors, which is connected to 14 and 27 GPIO pins of the ESP32 to measure distance from the trash. That is, when the trash is accumulated in the bin, as the bin is filled with the trash, when it reaches up to 80%, the bin will, that is the ESP32 will send notification to the user through the website, by which the user will be getting to know that the bin is going to fill. And then we have used humidity sensor that is connected to 13th pin of the ESP32, which measures the humidity level to distinguish between the degradable and non-degradable waste, that is wet waste and dry waste. Higher humidity suggests organic waste, while lower humidity suggests inorganic waste. If there's incorrect segregation, that is degradable waste is put into non-degradable bin or vice versa, then the ESP32 sends an alert to the user to ensure proper waste sorting. Then the ESP32. This is a device that connects to Wi-Fi, enabling it to send notifications when the bin is full or if the waste is placed in the wrong bin. Users can log into a dedicated website to check the trash level and if the waste is misput into another bin. Then 5-way adapter. We will require power supply to make this process work for all the devices. Hence, we'll require 5-way adapter. Then female adapter. The female adapter connects the 5-way adapter to the breadboard or components. Then the website now provides platform for handling smart dustbins and giving separate access points to the users, where it displays live data on the dustbin fills and also identifying between degradable and non-degradable waste. For the website creation, we have used following. For backend, we have used Firebase, which is used for saving and fetching data to the smart dustbin. It works as a support system in backend, enabling real-time database functionalities and works on maintaining the following. It maintains real-time database, that is keeps updated with the dustbin fill level to the user, and cloud storage to store the sensor readings, and authentication so that it is not accessed by any unauthorized users. And in the front end, we have used HTML, that is hypertext markup language, which is used to structure the content of the web page, basically to form the framework of the web page. Then CSS, that is cascading style sheets, is used to style the website, ensuring an appealing and user-friendly interface for displaying the sensor data and notification, like fonts, colors, background, and all this is used. JavaScript. JavaScript is used to implement dynamic functionalities on the website, enabling timely updates for displaying the current status of the smart bin. Now, the Arduino IDE. It is an integrated development environment and it is a key for coding and troubleshooting the ESP32 microcontroller in Smart Dustbin. It is also used for code development, library support, debugging, and is a user-friendly interface. This is basically a software platform for writing and coding the ESP32. And next, the circuit diagram. This is the circuit diagram. These are the ultrasonic sensors. This is ESP32 and this is the humidity sensor through which it will distinguish between the wet waste and the dry waste. Now, applications and future enhancement. Applications. Smart dustbin can be used in households, which automates waste segregation and disposal. In smart cities, enhances municipal waste management. Public places and schools, which ensures proper waste handling for hygiene and safety of people. Future enhancement. AI based waste recognition machine learning to improve waste categorization. Predictive analytics forecasting waste accumulation trends. Renewable energy source, solar panels for self-sustainable power. Mobile app integrations, users in future can also monitor bin status through a dedicated app. And now conclusion. Smart dustbin present a promising solution to the challenges encountered in waste management. By utilizing advanced technology like sensors for fill level detection and humidity detector to detect the type of waste being disposed in the bin, they can significantly improve the efficiency, effectiveness and sustainability of waste collection and disposal. With their capacity to monitor bin fill levels, segregate waste, and optimize collection, smart dustbins aid in fostering cleaner streets, minimizing environmental impact, and promoting improved public health. As cities continue to explore innovative approaches to waste management, smart dustbins have the potential to play a vital role in creating cleaner, greener, and more sustainable urban developments. These are the reference papers. Thank you.